We invite you now, the speakers, so we can start our debate. Dr. Monteiro, Dr. Rivière, Dr. Grangeiro, and I'd like to invite Dr. Maria da Graça Mota Melo, coordinator of the occupational dermatosis of Fiocruz in Rio de Janeiro. I would like to thank Professor William Weissman for inviting me to coordinate this debate. I would like to congratulate speakers for their quality of the presentations, the interest to the and the interesting subjects. We are all learning a lot, and the challenge of these interesting. It's interesting to see all these works together. I would like to ask Dr. Nancy. I work in occupational dermatology area, and we have contact dermatitis patients for sensitiveness to chemical products. Regarding nanoparticles, what we have nowadays is a reduction of this potential, or is there an increase, or is it variable, or do we have a lot of things to study about yet?
You're talking from an occupational standpoint where you see dermatitis cases. And yes, it's important, except I don't think we've worked long enough with nanomaterials to be able to see something long-term or an irritation. There's been no reported cases. I'm only familiar with a fullerene-based face cream that's caused irritation on people's cheeks using them on a daily basis. One of the major problems in, assessing toxicity to these nanomaterials has been no long-term studies that's been conducted. A lot of the studies, and even our research has been, as long as we've done, has been 2 weeks to see any type of irritation. And what you're talking is more of a chronic type condition. So unless we do these long-term studies, repetitive toxicity studies over a period of several months, I think then maybe you will see some type of long-term dermatitis cases. But no studies have been conducted to date with nanomaterials.
Ok, muito obrigada.
The debate is open for the public. Paulo Martin from the Research Network of Nanotechnology. It's a general question for the 3 members of the table. The theoretical framework of toxicology applied to larger particles than nano. So let's talk about microparticles. Is this able to answer the questions that have been asked by nanoparticles, or do we have to produce new theoretical frameworks that are specific to take care of the toxicology of nanoparticles?
I think I can add a couple of points on that. When you look at inhalational, there's been a lot of work on particles that in the past have gotten down to the nanoscale. When you look at other routes of administration, that's not true. Secondly, nano is an interesting term. It just says size. But the real unique aspects of nanotechnology are the unique material properties that occur at a nanoscale of less than 100 nanometers, the quantum effects on the surface. In that case, there's no way of extrapolating from larger particles or chemicals. We just need to define what's important and what isn't important and integrate that into the existing toxicology framework.
My name is Helena Zamici from Fiocruz. I would like to congratulate for the excellent speeches and would like to ask Dr. Grangeiro. He has informed that there are some references that are getting concerned to regulations. So I'd like to know if there is concerning toxicological assessment, are there basic directives that should be performed like any other chemical? Are these references being contemplating these sequence of batteries? Well, there is a set of protocols that ISO foresees for nanoparticles. Right now, we're trying to obtain these guidelines to assess and to implement. But this field is not completely standardized. There are several products and tutorial guides of recommendations in the shape of they're still suggestions. They're not yet defining protocols or attitudes regarding nanoparticles. Okay. She's not using the microphone. These suggestions, are they considering the existing methods? Is there are there yes? Yes, it is considered. Just like to answer the professor's question easier. We're starting our nanotoxicity works, but they came as a result of the experience in leading with nanoparticles for these medical applications I mentioned. So the stimulating factor was the remark that the material's property has changed completely, as the professor just mentioned. The hydroxapatite, we know as a macro or micromaterial, have completely changed, and the challenge we face in the laboratory at CVPF is to produce particles and keep them in nano shape. Because a few hours after the production of the material, because of temperature changes or natural dissolution of the material along time, will establish a balance with the bulk of the solution, will change the dimensional property of surface energy and reactivity. So since 2 years we're trying to tame this process to generate a stable material with calcium phosphate to study toxicity. We cannot do anything before that because we didn't have the controlled material. We still don't have it.
A comment? Yeah, can I make a comment? I just wanted to add to the comment on the question you mentioned about guidelines for nanotoxicity studies. I'm hearing Portuguese and English, but I can't think. One of the things that you mentioned with toxicology is that we don't even know which is the appropriate assays to use to assess toxicity. Unlike typical toxicity studies using typical MTT assays, neutral red assays, we've published 2 papers showing that nanoparticles, because of their size and their surface properties, they interfere with the assay itself. So when you get like the MTT conversion assay, the particle itself then absorbs that dye, so it screws the results and you may not get the appropriate results. So we had published a paper with 10 different viability assays showing how they all react. So if someone had used neutral red as their typical toxicity assay, you would always see toxicity. Or if you use like an Alamar blue or whatever. So what we found is that if you take every particle you're going to study and first look and do dynamic light scattering and to see how much the shift changes, and then we proceed with our assay test to determine the appropriate assay. So there's a lot of challenges because I don't know how anyone can go and make regulations now and say we should do these assays because we as toxicologists are still working on that. I'm in a project with the international harmonization where we're testing with several institutions in different countries and in the US where we take one cell type and we all try to duplicate it in the lab, we all try to do the same assay and see if we come up with the same results. to see what kind of problems. There's problems in cell culture studies with where you put it on the well plate, how much water that you put around for evaporated water loss. There's so many little technical, how long do you centrifuge your material in the solution before dosing? All that affects the agglomeration. We've shown with aluminum particles that when you put them in cell culture, and over time, they tend to agglomerate, and the size increases. So you're no longer studying the effect of nanoparticles, but large agglomerates. So until all these challenges and things can get worked out, it's kind of difficult to say, these are the protocols we're going to use, because every particle is so unique. So that's something to consider.
Sou eu.
May I add a comment coming back to this issue? There's a practical issue. We lived in a standardized step that happened. Professor Gutenberg made me reminded the following situation. ISO 10999 for cytotoxicity determines that we have to take a stratum of the material to do the analysis. We took this from the hydroxyapatites and made the assay of toxicity to confirm that it was not toxic. But toxicity still appeared. We almost made Alessandro Rossi drive crazy, because after what Gutenberg was able to show us is nanoparticles that we did not see were present in this stratum, and they were absorbing MATT formazan, absorbing the neutral red, and leading to a negative result. The conclusion is that we cannot use tests for standard material as if it was automatically appropriate. We know that nanoparticles cannot enter in the air, or other toxical products can be more toxic than nanoparticles, but I think this is a very important issue on this table. The relevance to show that Professor Riviere showed at the end, and Dr. Grangero as well, of a development that is quite important of toxicology, predictive toxicology of high quality, high performance, high capacity of resolution. Coming to that same aspect, if we consider the quantity of nanomaterials that already exist, if we test all these materials and all its moments, acute, chronic toxicity, this will never end. There are thousands of these materials nowadays. We did not test the bulk materials. Maybe we didn't test even 600 of them from the new materials. When we start to use the nanotechnologies, they will not be a novelty anymore. So what you have presented or started to present as new possibilities, new models, new predictive models, will be one of the essential steps for this path, to try to be creative in this search for understanding and anticipate what will happen in organizations, in living organs, trying to make traditional toxicology, we already know it doesn't work, to look for similar pathways in all particles. It may be something that is not factible. I think our time is over. Let me end the debates. If you have other questions, you can look for the speakers individually. I would like to thank them again, and for other components of the table. Thank you.